Welcome to the Explainer. So, today we're going to act a bit like mathematical detectives. We're uncovering the divine order hidden right inside proportional and non-proportional relationships. You know, if you've ever stared at a graph or some math equation and just wondered, what story are these numbers actually trying to tell me? Well, you are absolutely in the right place. We're going to decode the whole shebang together. Okay, let's dive right in by actually anchoring our lesson in this really powerful scripture. Let all things be done decently and in order. I love this because it reminds us that math, it's not just some random set of punishing rules meant to torture you. Instead, it's this beautiful, structured way to find patterns and bring total clarity to chaos, kind of like how God brings order to our lives. When we finally get how numbers relate to each other, we're literally uncovering the underlying order of the universe. Pretty cool, right?
Here's our roadmap for today. We're going to cover finding order in math, why these relationships matter, comparing relationships on graphs, spotting differences in equations, using tables to find order, and finally, wrap it up with some practice and true wisdom.
So, Section 1, Finding Order in Math. Let's lay down our core concepts first and really focus on our two big ideas for today, proportional and non-proportional relationships.
Think of proportional relationships as being, well, perfectly grounded. They've got a constant rate, and they absolutely must pass straight through the origin. That's the point 0, 0 on a graph. They literally start from nothing. Now, non-proportional relationships, on the other hand, they have this sneaky hidden starting value, and that starting value shifts the entire line upward or downward. They don't start at 0 at all. It's like they start the race with a built-in advantage or disadvantage.
Moving on to Section 2, why these relationships matter. Let's actually look at how this math works in the real world, far outside the four walls of your classroom.
Believe it or not, these math concepts apply directly to your everyday decisions. I mean, have you ever had to pick a cell phone plan? Or maybe tried to compare delivery apps to see which is cheaper? What about weighing two completely different job offers? Understanding proportional versus non-proportional math actually helps you spot when a situation involves a sneaky extra charge or some flat starting fee. By just recognizing what kind of relationship you're dealing with, you can completely avoid making a bad financial choice. It's a real game changer.
All right, Section 3, Comparing Relationships on Graphs. Let's put those detective hats back on and examine the visual evidence. So, here's the crucial point. Just being a perfectly straight line, that's not quite enough to make a relationship proportional. Check out Graph A and Graph B. Graph A is our proportional hero here because it starts perfectly at the origin, 0, 0, no extra baggage. But Graph B, it passes through the y-axis at 0, 4. That starting value of 4 is basically an extra fee or a head start, and that makes Graph B firmly non-proportional.
Up next is Section 4, Spotting Differences in Equations. Let's transition from those visual lines over to the actual algebraic rules.
When you look at these two equations side by side, you can almost instantly spot the difference that's breaking the mathematical order. I mean, equation A is y equals 2x. It's clean, it's simple, and it has absolutely no extra baggage attached. But then look at equation B. It's y equals 2x plus 6.
Notice that plus 6 right there? That is your major mathematical clue. It's the extra starting fee we've been talking about. Because that plus 6 exists, it entirely breaks the perfect proportion and just shifts the whole relationship up by 6. That means the equation is non-proportional. Seriously, anytime you see a plus or a minus a number tacked onto the end like that, your alarm bell should be ringing.
Okay, Section 5, Using Tables to Find Order. Let's look for some numerical clues to uncover that divine order hiding purely in the data itself.
Notice how Table A maintains this perfect, totally orderly, constant ratio. If we carefully divide y by x, so 5 divided by 1, 10 divided by 2, 15 divided by 3, we get exactly 5 every single time. That constant ratio right there proves it's proportional. Now look over at Table B. 6 divided by 1 is 6, 11 divided by 2 is 5.5, 16 divided by 3 is 5.33. See how the ratio changes with every single step? That right there shows us the mathematical chaos of a non-proportional relationship.
And finally, Section 6, Practice and True Wisdom. Yep, it is time to test your knowledge. Let's see what we've learned.
All right, question 1. Think back to our visual clues. Graph A passes exactly through 0, 0. Graph B passes through 0, 2. So, which of these graphs stays grounded at the true origin? Well, if you said Graph A, you are absolutely right.
Because it passes perfectly through 0, 0, it is for sure proportional.
Fantastic. Okay, let's look at question 2. Is the equation y equals 3x plus 4 proportional or not? Look really closely for any extra starting fees that might shift the order of this algebraic equation. Did you spot that plus 4? Yep, that extra baggage means this equation is definitely non-proportional. No way around it.
Let's tackle question 3. A table shows x equals 1, 2, 3, and y equals 4, 8, 12. So do the quick mental math with me and test if the ratio of y divided by x remains perfectly uniform. Okay, 4 divided by 1 is 4. 8 divided by 2 is 4. 12 divided by 3 is 4. It's a constant rate across the board, so yes, this is absolutely proportional.
Moving right along to question 4. Compare these two side by side, y equals 5x and y equals 5x plus 2. Can you find the one harboring the hidden starting value? Which one is non-proportional? You guessed it, it's the second one, y equals 5x plus 2. And that's all because of that extra plus 2 shifting the entire line.
And finally, question 5. Let's put it all together. What two visual rules must a line absolutely follow to maintain proportional order on a graph? Well, first off, it must be a perfectly straight line, representing that constant rate. And second, it absolutely must pass directly through the origin, 0, 0.
You guys did fantastic today. To conclude our explainer, I really want to leave you with the core philosophy of the Hero Smart Academy Godly Learners series. We intertwine biblical morality with education because, honestly, education without morality will ultimately just hurt us. Think about it. What is the point of being mathematically smart and highly educated if we just continue to make bad choices in life that hurt ourselves and others? Romans 8, 6-7 actually promises peace of mind to everyone who keeps their mind spiritual. Just as finding the divine order in math brings absolute clarity to a problem, keeping our minds aligned with spiritual order is what truly brings lasting peace. So, as you look at the trajectory of your own life today, I want you to ask yourself, are you building out a solid, grounded origin, or are you carrying hidden baggage that's throwing your whole equation off course?